Hi everyone, so this is video 2 in a series of bashing Geo with complex numbers. So go check out video 1 if you haven't already. Otherwise this stuff will be new. Alright, so let's get started. So we reviewed some basic formulas and unit circle stuff last time, and let's review a few more things and then we'll get started with an example. So let's just say we have 4 random points, A, B, C, D, and we want to find the intersection of let's do A, B, and C, D. And this is the unit circle. So what's the intersection of these two lines? So let's just say they intersect at a point P, and let's call the complex numbers corresponding to A, B, C, and D, A, B, C, and D. And so there's a theorem that the point P is AB times C plus D minus CD times A plus B over AB minus CD. Okay, so this is useful to know, and there's a formula for this if A, B, C, and D are arbitrary points that don't necessarily lie in the unit circle, and that is a lot more complicated. And how to derive this formula from that formula is, so that formula, the formula where A, B, C, and D are just arbitrary points, will have a lot of conjugates, and you can replace them with 1 over A since it's the unit circle. See the last video if you don't know how this works. Okay, so that's that. And so now let's look at perpendicular and parallel lines on the unit circle. So let's get up the unit circle again. And let's add 4 points. And so the first thing that's up is how do we tell if how do we tell if AB is perpendicular to CD? If they're all in the unit circle. So the theorem is these are perpendicular if and only if AB plus CD equals 0. And so in this case, if, for example, if this is A, this is B, and this is C, and we're trying to find the coordinates of D, then it would be negative AB over C. Okay, so that's a useful thing to know, and try proving this as an exercise with the collinearity condition that we'll discuss later in this video. Alright. Okay, so that's good. So now let's move on to parallel. So we have this unit circle again, and then we have these two lines. And this diagram is it's not exactly good, but it's fine. So how do we tell if AB is parallel to CD if they're all in the unit circle? So the theorem says that this is true if and only if AB is equal to CD, or AB minus CD equals 0. And this is not that hard to prove as an exercise. Try using the last theorem. Try using the last theorem that we just found and try to prove this. Okay, so that's that's 2 more unit circle theorems. And now we'll move on to how to find collinearity and then another example. So a lot of problems will ask you to prove that 3 points are collinear. And if you have all the complex numbers corresponding to those points, how do you tell if they're collinear? So let's just say we want to prove that A, B, and C are collinear, and A is A, B, and C, like that. And so we want to see if A, B, and C are collinear, and we have their complex numbers. So it's true if and only if A minus B over A minus C is a real number. So for example, if A is 3 plus 4i, and then B is, let's say, 3 plus 2i, this diagram is not accurate, then we know that A minus B is 2i, so we need A minus C to be pure imaginary, which means that C must be also in the form 3 plus some xi. But that's pretty obvious just intuitively. All right, so this must be real. And how do we tell that if this is real? So what we do is we take the conjugate, because a useful property is that real numbers are their own conjugate. And this is pretty easy to prove. So if this is true, then it's real. Then a minus b over a minus c is real, and the 3 points are collinear. Okay, so now let's go on to the example. All right, so here's this is about Simpson lines. Okay, so we have a triangle. So we have the unit circle, and then we have a triangle, ABC on it. Let's correct that. It's fine. A, B, C, and we have a point D on the circumcircle. And then we have these feet of the altitudes, so like these 3 feet. And for those of you who know Simpson's line, you'll know that these 3 feet are collinear. Collinear. And you can prove this using complex numbers by using the foot of the altitude formula, then using the collinearity test. And let's just say the orthocenter is H, and we want to prove that this is called the line connecting these 3 points is called the Simpson line. And if you don't know just assume that it exists for now for this problem, but it's easy to prove using complex numbers. And then we want to prove that the Simpson line bisects DH. So I'll just draw that in a different color. So we want to prove that the blue line bisects the red line. Okay, so this looks good using complex numbers. So this is the unit circle, ABC. So we know that the orthocenter is A plus B plus C, and let's just say this is D. So we want to prove that the midpoint of DH is on the Simpson line. And the midpoint of DH is A plus B plus C plus D over 2. And so we just want to find the 2 points on the Simpson line and then prove that they're collinear with A plus B plus C plus D over 2. So let's just find the 2 circled points. So this one is going to be A. So this is going to be 1/2 times A plus B minus AB D prime. A D conjugate, which is also A plus B minus AB over D. Because D conjugate is equal to 1 over D when D is on the unit circle, which it is now. It's A plus B plus D minus AB over D. And similarly, the other circled point is 1/2 A plus C plus D minus AC over D. So we have all these with 1/2 in them. And so let's just multiply all of them by let's just multiply all of them by 2, because we just want to prove that they're collinear now. And if we multiply all of them by 2, that won't change anything. So we want to prove that these 3 points are collinear. Okay, and now let's do the test. So we want to prove that A plus B plus C plus D minus A plus B plus D minus AB over D, that over A plus B plus C plus D minus A plus C plus D minus AC over D. We want to prove that that's real. And so this, let's just clear the diagram because we don't need it anymore. And that is equal to, I'll just write it up on the top left now, and that is equal to C plus AB over D over, and then that's B plus AC over D. Okay, and this is equal to CD plus AB over BD plus AC. And the only thing left is to prove that this is real. And so to do that, we take the conjugate, Wait, hold on. I swapped that. But they're the same, so it doesn't really matter. So CD plus AB over BD plus AC. Okay, so a nice property about conjugates is that it's like, so here's some nice properties about conjugates. Like we can just split this up into this, like always using conjugates. And we can split this up into this using conjugates. And note that all of these points in this expression lie in the unit circle. So its conjugate is equal to 1 over itself. Shoot, what's happening? One over AB over 1 over BD plus 1 over AC. And so now we want to prove that this is equal to this. And this, by multiplying everything by ABCD, is just AB plus CD over AC plus BD, which is clearly the same thing as this. So these are equal, so the 3 points are collinear. So that's the end of this video. If you liked it, please like and subscribe. Thank you.